Hi folks, this is part 2 of Unit 7 Lesson 1. We're just going to take up these questions using the quadratic formula here. So first thing I'm going to do is on the side is write out the quadratic formula. So as I said, you should start memorizing this. So the quadratic formula is x is equal to negative b plus or minus square root of b squared minus 4ac all over 2a. And you see the way I say it out loud? That's what you should be saying it in your head as you're writing it out. And then eventually, you won't even need to do that. All right. So one thing that I might suggest at this point here is to actually indicate what the A, B, and C values. So before we start, it says determine the x-intercept. So you should be specifying that what you're solving is the equation where the y value is equal to 0. Okay, trust me, how that's going to become important later on when we start using the quadratic formula beyond just finding x-intercepts. So be very specific that you're finding when y is equal to 0. Then what I might suggest at this point here is to specify what the a, b, and c values are, just so that you don't make any mistake with the sign. So the a value here is negative 2, the b is equal to positive 3, and c is equal to positive 3. So that now all you're doing to solve this equation is inputting these values into the quadratic formula. Okay, so negative b, so negative 3 plus or minus square root of b squared, so 3 squared minus 4 times a is negative 2 times c is 3 all over, and remember that this whole thing is divided by 2 times a, so 2 times negative 2. Okay, now the next thing I would suggest doing is simplifying the input to the square root and the denominator, and then from there inputting that into your calculator if you need to find an approximation. So here we have negative 3 plus or minus the square root of, so you can do this in your head or do it on the calculator. So it's 3 squared is 9. This is going to be plus, okay, 4 times 3 is 12, times 2 is 24, so 9 plus 24, okay, looks like it's going to be 33, but let's just check it just to be sure. Okay, so 3 squared, so 9 minus 4 times negative 2 times 3, and there we go, it was 33. Now you can leave this as your final answer if there's no context to this question. So the x-intercept doesn't represent some time value. You can actually leave this as your answer. It's 2 answers, but let's find an approximation here because we are going to check the graph on Desmos to make sure everything makes sense. And of course, it's going to give some approximation. So as you're calculating this, remember this whole thing has to be divided by negative 4. So your 2 options, and I'll do it both ways. One option is to make sure you put brackets around the numerator if you're going to do everything in one shot. So bracket negative 3 plus square root of 33, close the bracket, divided by negative 4. Okay, so one of our answers is going to be negative 0.686. Or the other way you can do it is to do it in 2 steps. Is first calculate the numerator, press equal, so you see what I do. So the next one is negative 3 minus square root of 33, press equals, and then from there divide by your denominator negative 4. Okay, 2.186. All right, so based on what we found, the quadratic formula shows us that there's 2 x-intercepts. All right, so let's take a quick look at Desmos to see if this makes sense. So let's take a look at this first one, and we see that we have 2 x-intercepts, and if I check, there you go, negative 0.686, exactly what we found, and 2.186, again, exactly what we found. All right, so let's go do the next 2, and then we'll test them out on Desmos at the same time. All right, so let's do this one here. So again, I would suggest specifying, so a is equal to, there's nothing in front of the x squared, so it means a is equal to 1, b is equal to negative 3, and c is equal to 7. All right, so let's, again, specify that we're finding the x-intercepts by replacing y by 0. All right, and so now this equation, the formula gives me the solutions automatically. So negative b, so negative of negative 3, plus or minus the square root of negative 3 squared, b squared, minus 4 times a, which is 1, times c, which is 7, all over 2 times a, and a is equal to 1. Okay, so let's clean this up before we put in our calculator. So this is going to end up being positive 3, plus or minus. All right, so let's put this in our calculator here. So negative 3 squared is 9. Okay, minus 4 times 1 times 7 is equal to, negative 19. Well, here's where we hit a bit of a snag, because you can't take the square root of a negative number. Okay, so what does this mean? How do we interpret this result? Well, it must mean that there's no x-intercepts. Okay, meaning there's no solutions to this equation, but we shouldn't be surprised because we know that some quadratics do not have x-intercepts. Okay, and we'll confirm that later on. So now you know that if in doing your in going through the process of using the quadratic formula, if that number inside the square root turns out to be negative, the interpretation is that this function must have no x-intercepts. Okay, so let's do this last one. I'm wondering if somebody noticed something interesting about this last one. And if you didn't, I think we'll see it in a second. So again, replace y by 0 since we're finding the x-intercepts. Okay, eventually you won't need to do that, but for now I'm going to specify what a, b, and c are. So a is 0.09, b is equal to negative 0.3, and c is equal to 0.25. So the solutions to this equation are given by the quadratic formula. So x is equal to negative b, so negative of negative 0.3, plus or minus, okay, square root of negative 0.3 squared, okay, minus 4 times a, which is 0.09, times c, which is 0.25, okay, all over 2 times a, which is 0.09. Okay, so let's, again, clean this up. This is going to be positive 0.3 plus or minus. In the denominator, this is just going to be 0.18, 2 times 0.09. Okay, so let's put square root there. So it'll be square root of, so we have negative 0.3 squared, okay, minus 4 times 0.09 times 0.25, and look what we get. We actually get 0. Okay, now again, this is another interesting scenario because here the square root of 0 is just 0. It doesn't make a difference whether I add 0 or subtract 0. It's not going to change the numerator at all. So this is just going to be 0.3 over 0.18, which we could estimate as, okay, let's do that here, 0.3 divided by 0.18, okay, so about 1.67, or if we wanted to put this in really a nicer way, how would we do this? Okay, how do we put this in fraction form? Well, first thing you want to do is get rid of these decimal places here. So what you can do is multiply. In order to get rid of the decimal here, I'd have to bring that over twice. So I'd be multiplying numerator and denominator by 100. Okay, so that would give me 30 over 18. And these are both divisible by 6. So this is just going to be 5 over 3. And 5 over 3, 1 2/3. Yeah, that's the approximation for it. All right. So let's take a quick look at Desmos to see if these things make sense graphically. Okay, so let's do the second one here. And look what happens. There's no x-intercepts. So looks like we had the right idea. And when we look at this third one here, we see that there's only one x-intercept at 5 over 3. Okay, so it just touches the x-axis. All right, so let's just go do a quick recap. Okay, so quick recap. Well, most important thing is you need to learn the quadratic formula. You need to know that formula by heart. Second of all is to realize when you can use it. So when you have an expression in standard form equal to 0, so very important, it has to be equal to 0, then the quadratic formula gives you those answers automatically. And you have 3 possible scenarios. Okay, as we have with quadratic functions, you could have 2 answers, no answers, or you could have 1 answer. Okay, Now think about it here. I said there was something special here, so you might want to think about it a little more. But if there's only one answer, then it must mean that this is a perfect square. And see if you can figure out, why that makes sense. And if I look at 0.09, 0.25, those definitely look like perfect squares. All right, that's it for this one.